All right, so in this video, I'm going to cover a couple of problems in online homework. Okay, so online homework is 7.4. So yeah, I gave hint of the problems, online homework problems, 7.1 and 7.23. Okay, so I think a couple of weeks ago, and now we see a couple problems in 7.4. So uh, the first one is the seven uh, chapter 7 visual problems, chapter 7 section 4 problem 1. Okay, so 7.4. Okay, so this is problem 1. Okay, so question is this. I know this the camera is out of focus, right? So let me fix it once I just done with writing the problems. So we're going to consider the PDF. Okay, so f of x is defined by 4y cubed and the alpha to the negative fourth power and the e to the negative y over alpha, the fourth power, and the alpha, y is greater than or equal to 0. Okay. Otherwise 0, and y is less than 0. Okay. So the question is this, find the maximum likelihood estimator for alpha. Okay. So the question is to find out the MLE of alpha. Alpha is the population parameters. Okay. Okay. So let's see. Okay, so first we need to figure out what the likelihood function, right? So give me a second. The L of alpha. Okay, so that's gonna be L of alpha. It's gonna be what? Pi of right. So I goes 1 to n. The f of xi. Let me call one and alpha, right? Okay, so we can, yeah, the again. So this is nothing but f of x. It's just different notations. Okay. So since the alpha is unknown, the parameters, we can express denote the PDF as f of x colon and alpha. Okay. So but anyway, so xi is observations, right? I mean the sample data in a random sample. So now this is equal to the pi I equals 1 to the n. Okay. Excuse me. So, by the way, let's see. Yeah, it's okay. This is equal to 4, right? And then, yeah, sorry, it should be right? Sorry, because we here in this problem use the letter y as for the sample observation, right? So it should be y. Sorry. So 4 times yi cubed and then alpha to the negative fourth power. Okay. And then e to the negative yi over alpha to the fourth power. Okay, that's 4. Okay. So now that is equal to, you see that 4 and then alpha to the negative fourth power and the e to the negative 1 of alpha to the fourth power, these are just constant, right? Because y sub I is not involved, so we can bring them out of the pi. Okay, so we get this. We got 4. Okay, alpha to the negative fourth power. Okay, and then you see that. Look at this. What? Since we can't just the 4 and arbitrary negative force. Let me just leave a negative 1 of arbitrary force power just like right here. Okay. So let me just take out the 4 and arbitrary negative force power out of the pi. But when you take them out, uh, we you have to consider that what we multiply. What does the meaning of pi? It means that we multiply 4 n times, right? And then we multiply up to the negative fourth power n times. So we're going to get 4 to the nth power and then up to negative 4 to the nth power, which is negative 4 times n. Okay, keep in mind this. the pi I goes 1 through the n, and yi, see, to the third power, and the e to the negative yi over alpha to the fourth power. Okay. So now we're gonna take, yeah, so definitely we'll find the critical value, right? So, but let's find the critical value of natural log of the likely function. That's what stress we learn, right? So natural log, we take natural log, and then L of alpha, okay? So that is equal to, so taking natural log of this, all the multiplication is gonna be, separated as a sum of natural log of each one, right? So that's gonna be n times natural log 4, okay, and then plus, and then negative 4, which is negative 4n times natural log of alpha, and then plus, see, what, second, so natural log pi, I goes 1 to the n, and then yi to the third power e to the negative yi over alpha to the fourth power, okay? So look at this, look at this, this is equal to, let's see, that is equal to, by the way, that is equal to what? See, natural log, I mean, let's see, give me a second. Yeah, so that is equal to, what? Natural log. Give me a second. So just take a look at this one, okay? I know this, the pi is, what? This is pi of yi cube times e to the, exponential term, but this one right here is equal to, I mean, natural log, I mean, this one, pi I 1 n yi cube, this one, that is equal to, the plus natural log e to the, I mean, pi I goes 1 to the n, okay? So now let me see, minus yi alpha to the fourth. If you don't understand, but think about this. Natural log, example, a times, you know, b times, let me see, a1, b1, a2, b2, okay? So think about this. Natural log of a1 times b1, let's say a1 times b1 times a2 times b2. Then we can say that this is equal to natural log a1 times a2, right? And then b1 times b2. We just rearrange them. So now this is equal to what? The natural log of pi I goes 1 through the 2 ai, right? Is it? And then plus natural log pi I goes 1 to the 2 and then bi, is it? We can say that, right? So in the a1, b1, a2, b2, that is actually pi I goes 1 to the 2 and then ai, bi. We can say that. Now we see that how we can express this one as a sum of two natural log of pi, right? So now that is equal to, now then this is actually what? I mean, that is actually natural log y1 cube, right, times y2 cube times through the yn cube, right? Plus this is equal to natural log e to the minus y1 over alpha to the fourth power times e to the negative, y2 over alpha to the fourth power through the e to the minus yn over alpha to the fourth power, isn't it? So then what we get? Now we got this. Then because the natural log pi I goes 1 through the n. So yi cube times e to the minus yi over alpha to the fourth power. This is equal to the natural log pi I goes 1 through the n yi cube plus natural log. Okay, and then pi I goes 1 through the n e to the minus yi over alpha to the fourth power. This is equal to, okay, No, give me a second. Okay, so now is equal to what? This is sigma. Look at this. Natural log of the product of yi can be expressed as what? The sum of natural log of yi, right? So there's I. So the pi is change, change to the what? The sigma. Okay, and the natural log yi. Okay, q, and then cube right there, and then minus this one, and then y 1 over alpha to the first power, and then sigma. Second natural log sigma, right? I equals 1 to the n, natural log e to the, yeah, give me a second, minus yi. But we already take out the negative side, right? E to the, just yi to the first power. Yes, right. Okay. But see that natural log e to the yi to the first power is equal to just yi to the first power. Okay. So now this is equal to, I mean, so now the natural log of likelihood function L of alpha is equal to n times natural log 4 minus the first, we got the first two term right there, right? So I just copy this one. So minus 4n natural log alpha, and then plus 3 times, you see that 3? Because this is natural log yi to the third power, we can bring it out, right? 3 times sigma I goes 100 and the natural log yi, and then minus 1 over alpha to the fourth power, and the sigma I goes 1 through the n yi to the fourth power. Okay, and then now we're gonna take what derivative of this guy with respect to alpha. Okay, so d natural log L of alpha divided by d alpha. Okay. Then the natural n times natural 4 is just gone. This is gonna be 1 over actually the what negative 4n over alpha, right? So negative 4n over alpha. And then derivative this, well, the alpha is not involved, right? So this is gone. And the derivative of this one is what? Let's see, plus, because the derivative of 1 over, this is constant in a view of alpha. So taking derivative of 1 over alpha to the fourth power is what? Minus 1 over alpha to the fifth power. There is one more negative sign. So we got plus 1 over alpha to the fifth power. Okay, and the sigma I goes 1 to the n, and then yi to the fourth power. Okay, so we have to solve what? We have to solve this one is equal to 0, right? Because we want to find a critical value. So the then give me a second. So now let's see. We need to isolate alpha, right? So let me multiply alpha to the fifth power. Then we're gonna get negative 4 and alpha to the fourth power, and then is equal to what? Minus sigma I equals 1 to the n and the yi to the fourth power. It means that alpha to the fourth power is what? 1 over 4n sigma I equals 1 to the n yi to the fourth power. So alpha is what? Definitely plus minus sign, right? The square root. Okay. So give me a second. Let's see. Plus minus right there. Okay. Let's see. Did I miss something? Yes. This is 4, right? Sorry, this is 4. Okay. So Yeah, because derivative of the 1 over alpha to the fourth power is a 4 over alpha to the fifth power minus 4 over alpha to the fifth power. So that means the 4. So there is actually negative 4. So we got 4. Okay. So 4 right there. So 4 over 4 is 1, right? So we got 1 over n. So 1 over the fourth root over 1 over n sigma I goes 1 to the n yi to the fourth power. Okay. So but see, problem says that find the MLE for R positive alpha. So we drop the negative sign. Okay. So this is answer. Okay. So this is MLE of the parameter alpha. Okay. Let's see next problems. The next problem is about the let's see. Deviation estimator. Okay. So I think you need to look at the problems. So give me a second. Yeah, can you see this? Give me a second. Yeah. So here's a question. The length of the manufactured component is a normal random variable with a unknown mean and the known variance. So mean is unknown, okay, and then variance is known, 0.4 centimeter square centimeter. The prior distribution for mu is normal with a mu 0.20, sigma 0.20, sigma 0 square is 0.01 square centimeter. So random sample of 10 components was taken, and their length is centimeters are 20, 19.93, 20.05, 19.99 through the 19.91. So round your answer to 3 decimal places. Find the base and estimate of mu. Okay, mu tilt. See that? And then find the probability that mu is greater than 20. So let's figure out that. So see. Now let's see. First one, we need to figure out the what f of mu. Okay, which is the give me a second. So which is the prior. Give me a second. We need to figure out the wait. First, we need to figure out. Let me write down the formula of posterior distribution. Okay, so that's the oh, we don't, yeah, so this is equal to percentage distribution is what? Half of, in this case, mu, right? Mu bar, and then x1 through the xn. This is equal to, so f of x1 through the xn, comma mu over f of x modular distribution, right? Xn, right? Okay. See that is equal to, this is equal to, this is the joint distribution of the sample and parameter mu, right? Can be expressed as f of x1 through the xn bar to mu times f of mu, okay, over f of x1 through the xn, right? Okay, so this is the prior distribution of mu, okay, and that is what? The joint distribution of sample, and that's the joint distribution, oops, of sample and mu, okay, parameter, okay. So the Bayesian estimator is a mean of a posterior distribution, okay. So we're not going to, but in this problem, we're not going to use this formula, okay? Because the problem says that what? The length of manufactured compound is a normal random variable. Okay, and then also prior distribution is also normal. So this is exactly same conditions, assumptions in the example what we sell in the textbook. Okay, so we're gonna use the result of that example in textbook. Okay, so to solve these problems. So now, give me a second. The what? Um, the first one, then posterior f of mu bar x1 through the xn. Okay, this is the normal distribution. So, what? The prior distribution of mu is normal with the mu zero and the sigma zero square, right? Then we it turns out that the posterior distribution was a normal. Okay, this is a normal. Okay, probability density normal PDF. Okay, with posterior mean. Posterior mean. What? This is the sigma square over n, and then mu zero, and then plus sigma zero square, the x bar over sigma zero square. That one is in the next lecture notes. Please look at that. Okay. And then I just and then I covered that lecture note. Okay. So this one and the posterior variance is what? Sigma zero square, and then sigma square over n over sigma zero square plus and sigma square over n. Okay. Now the we can find out x bar. So by the way, sigma zero, the what? Sigma zero square is given, right? Well, all we know is all the for these parameters, the specific value of these parameters, the values are given in problem except for what? The sigma, right? Okay. So now this mu zero was given. Problem says the mu zero is 20. This is the what? The mean of the prior distribution. So prior distribution mean is mu zero, which is 20. Let me skip writing unit centimeter. Okay. And the sigma zero square is 0.01. Okay, and the n is 10, right? 10 component. All right, so x bar, we can find the x bar because the sample, random sample is given, right? So x bar is 1 over n. The sigma I equals 1 to the 10, and then xi, which is the, calculating this, we're going to get 19.985. This is what we have to calculate. You can use a calculator or just do by hand, okay? So we're going to plug in these numbers into here and here, okay? But yeah, so now then, we're going to get this. Then Bayesian estimate, okay, let's say BE, Bayesian estimator, mu tilde is equal to, give me a second, let's see. All right. So now the what? Give me a second. Oh, forgot one more things. The variance, right? The population standard deviation. Population what? Variance is given 0.4. Sorry, this is all given. So we know sigma square. We know n, mu zero, x bar, sigma zero square. All the the parameters are given, right? Okay, so we can find out this one, we can find this. So the only thing, the only thing what you have to do is just plug in all these numbers into the formula, posterior mean and posterior variance. Okay, so that's gonna be 0.4 over 10, I see 0.4 over 10, and then mu zero is 20. and plus sigma 0 square, which is 0.01 times x bar, which is the 19.985 divided by sigma 0 square, which is 0.01 plus sigma square, which is 0.4 over and 10. Okay, so calculating this, we're gonna get 19.997. I mean, rounding the three decimal places. Okay, so now the this is A. And then second question, find the probability that mu is greater than 20, which is we want to find the probability that mu is greater than 20. Okay, so keep in mind this, what? The mu, I mean, what? The, that's going to be what? So I think the here, yeah, I'm sure that the problems is not just find the probability mu is greater than 20, mu tilt, okay, because we don't know mu, so, right. So now, give me a second. Yeah, so it's a should be typo. So mu tilt. Remember that the mu tilt, which is the Bayesian estimator. So now, which is the mean of mean of posterior distribution. But posterior distribution is normal distribution because the prior distribution is normal distribution. Okay, so we can use the normal distribution. So this is equal to what? We use the what? We can find the what? Give me a second. We can use a calculator. Okay. So we here. So we use go to the distribution. Okay, we just click the normal PDF, normal CDF, CDF. Okay. So lower must be greater than 20. So 20 is must be lower. Upper is 999. The mu, in this case, what? Um, now it's gonna be give me a second. 19,997. Okay. So 19,997. And then sigma. You see that? Right here, posterior mean is here. This is the we use this one as mean. Okay. And then this is the variance, right? Okay, let's find the variance. So now right here, the sigma tilt square, that's gonna be sigma 0 square, which is 0.01 times sigma square, which is 0.4 over 10, divided by sigma 0 square is 0.01 times sigma square of n is what? 0.4 over 10. Okay, calculating this, we're gonna get the 0.008. Okay, so then what? Standard deviation here, the sigma is a standard deviation, right? So we take the square root of 0.008. So square root 0.008. Okay, so we got the 0.48662, but rounding to get the three decimal places, we got 0.487. So this is equal to 0.487. Okay, so the yeah, you can say it's just mu, but mm, um, yeah, let's see. Okay, so I think a mu tilde should be okay. Okay. So what that means here, find the, give me a second. Here's a 19.997 right there. Okay. So this is a normal distribution right here. Okay. And the sigma, this is mu tilt. And the sigma tilt square is 0.008. Okay. So let's say this is, yeah, this is, yeah, you can see the mu tilt, but yeah, so it's kind of confusing, right? So this is the graph of the Second, posterior mean, a posterior distribution. Okay. So which is f of mu or x1 through the xn. Actually, x10, right? Because n is 10. But, okay. So now the mu tilt is greater than 20. So we're gonna find the mean of actually mean, right? Mean of the mu bar. We find out. I mean, we the p of mu tilt is greater than 20 is the probability that the what a posterior mean is greater than 20. But posterior distribution is a normal, so we can use we can calculate this one using the using the formula of G score. But instead of you doing by hand, I use calculator. Okay. So now let me stop here. Okay. So that was the two problems. So I hope that will help you to work the online homework problems.